After the applications of trigonometric identities in exercise 3.3, the next topic is about trigonometric equations. In this section, we will know how to find solutions of trigonometric equation. Solution to a trigonometric equation would mean finding the value of the variable, and in this part, trigonometric equation's variable is the angle, that is a theta or x. After solving, if we get the angle theta or x lying between 0 to 2 pi, that means 0 included, 2 pi not included, up to 2 pi, then such a value of theta or x or that solution is called the principal solution. And if the solution involves the integer n, if the solution is written in form of integral multiple of the angle, then such a solution to the trigonometric equation will be called as a general solution. So let us begin with finding solutions to the trigonometric equation. Before we start solving them, we should know three theorems. The first theorem is for all real numbers x and y, if sin x is equal to sin y, that would mean, that implies that solution to this equation, that means in trigonometric equation that involves sin x equal to sin y, solution to this equation will be the value of x in terms of y. So for all real numbers x and y, if sin x equal to sin y, that would mean that x is n pi plus minus 1 to the power n y, where n belongs to the set of integers. First, let us prove this theorem, and then whenever we are given a question that involves a sin x equal to sin y, directly we will write that solution to that equation is x, which is n pi plus minus 1 to the power n y. Now first prove that this is true or not. Since sin x is equal to sin y, this is the given statement. In that case, we can write this as sin x minus sin y is 0, and we will apply the trigonometric identity sin c minus sin d. Sin c minus sin d is a 2 cos c plus d by 2 times sin c minus d by 2 equal to 0. Everything is in product form, so 2 cannot be 0. So either this is 0 or this is equal to 0. So if cos x plus y by 2 is 0, or if sin x minus y by 2 is 0. If cos of this is 0, then what should be x plus y by 2? Cos of which angle is 0? So you know that cos 90 is 0. So cos of odd multiples of pi by 2 is 0. That means we will write this implies x plus y by 2 is odd multiples of pi by 2. Odd multiple means a 2n plus 1. This is called odd multiple of pi by 2. Either sides we can cancel 2 and we will get x plus y is odd multiple of pi. Right now, transposing y, we will get x is equal to 2n plus 1 pi negative of y. So this can be written in a proper way as x is 2n plus 1 pi. Instead of writing this minus sign, we can write it as plus negative 1 to the power odd 2n plus 1, so that we see some symmetry here. So negative to the power odd is negative, and that is due to which we have a negative sign here. So this we have written in this form, and then there is y. So from this part we got solution to this equation as this. What about this side? Sine of which angle is 0? Sine of 0 is 0, sine 180 is 0, sine 360 means 2 pi is 0. Its meaning is, so from here we will write x minus y by 2 is here on cross multiplication we will get x minus y is 2n pi. Ultimately x can be written as 2n pi plus y. So here the way we wrote negative 1 as negative 1 to the power odd. So here also we will write in that way. So x is 2n pi plus fine. But here 1 is there. So 1 to the power even. So that we see a symmetry here. And here minus negative 1 to the power even. So the symmetry negative to the power even is always positive. In that way the plus sign is justified. And then there is y. So if sin x equal to sin y, then what is a solution to this kind of a trigonometric equation? Solution is either x is this or x is this. So these two we can generalize and we can write a solution. So therefore, if sin x is sin y, the solution to the given trigonometric equation can be written as x. And you just see the symmetry. 2n plus 1, 2n plus 1, rest all are same, pi plus minus 1y, pi plus minus 1y. So these are same. So we can write solution as x is n pi plus minus 1 to the power n y. So whenever we are given a trigonometric equation in form of sin x equal to sin y, the solution should be x is equal to n pi plus minus 1 to the power n y. The next theorem that we will use for finding solutions to the trigonometric equation is theorem 2. It states that for all real numbers x and y, if cos x is equal to cos y, then solution to this equation, this statement implies that x should be 2n pi plus or minus y. So this is like next time we see a trigonometric equation as cos x is equal to cos y, we will write its solution as x, which is 2n pi plus or minus y. So let's do the proof to this so that we confirm this equation. So since we are given that cos x is cos y, we transpose this and we will get this as cos x minus cos y is 0. This is cos c minus cos d identity. Here we will apply in the left side. Cos c minus cos d is negative 2 sin c plus d by 2 times sin c minus d by 2 is 0. So negative 2 can't be equal to 0. So either this is 0 or this is 0. So either sin x plus y by 2 is 0 or sin x minus y by 2 is 0. So sine of which angles are 0? We know that sine 0 pi is 0, sine pi is 0, sine 2 pi, 3 pi, 4 pi. Sine is 0 along x-axis, positive x direction angles and negative x angles direction angles, sine is 0. So sine of multiples of a pi is 0. So here we can write x plus y by 2 is multiple of a pi. So in place of n, 0. Then sine 0 is 0. In place of n1 means sine 180 is 0. Then sine 2 pi is 0, 3 pi, 4 pi, like that 0. Cross multiplying this, we will get x plus y is a 2n pi and y we will transpose, we will get x is equal to 2n pi minus y. So we will have it and parallel space we will solve this. Sine of which angle is 0? Sine of multiples of a pi is 0. So x minus y by 2 is n pi, where n integer, set of integers. On cross multiplication, we will get x minus y is a 2n pi. N belongs to the set of integers. So here x is a 2n pi plus y. Now this is the solution whenever cos x is equal to cos y. The solution is either x is 2n pi minus y or x is equal to 2n pi plus y. So these two we have to combine or we have to generalize to give one solution. So if our trigonometric equation is cos x is cos y. That implies it's a solution, general solution. Solution is x, which is 2n pi plus or minus y. So solution to this trigonometric equation is x is a 2n pi plus or minus y. The next theorem to find solutions to trigonometric equation is theorem 3. It states that for all real numbers x and y, if tan x is equal to tan y, tan x is tan y, that implies meaning is solution to this equation. That implies that x is n pi plus y, where n belongs to the set of integers. So whenever we see a trigonometric equation of this form and we are supposed to find solution is a value of x, which is n pi plus y. Now let's prove this to verify the formula and the solution. So if tan x is a tan y, we transpose tan y, we will get tan x minus tan y is 0. We bring this to simple form, that is sin x by cos x minus sin y by cos y is 0. LCM of the denominators, this is cos x into cos y. Go for simple cross multiplication. We get sin x cos y minus cos x sin y, right side 0. The numerator is in form of sin a minus b identity. So the numerator is sin x minus y and denominator, when for cross multiplication, turns 0. Now sine of which angle is 0? Sine of integral multiple of a pi is 0. So that would mean that x minus y is some integral multiple of pi. N belongs to the set of integers. We transpose y. So solution to the trigonometric equation tan x equal to tan y is n pi plus y. Now we will see the applications of these three theorems in the coming exercise. The exercise 3.4, two sets of questions. Find principal and general solution of the following equations. 4 bits are there. And 5 to 9, find general solutions of the following equations. So we will begin with the first question.